Well, this is the initial test run with it plugged into the harness and all of the supporting hardware, most of the supporting hardware. I don't have the PA mic hooked up to it yet, but the PA amplifier and the DC-DC converter both work, so that's a pleasant surprise. I didn't expect anything different, but it's always nice to see confirmation. So you see that I have this yellow jumper wire manually running to this 8-volt regulator down here. Yes, that's 8 volts, 7808. And the reason for that regulator is to power the microphone, which I was doing earlier to test the preamp and the volume levels. The preamp volume adjuster is right back there. It's that little blue box. It's going to be hard to make out on the video, but I have to have it adjusted prior to installation. So everything seems to be working. APRS over there isn't working yet. Still have to debug that and figure out what's going on, but I knew that going into this. The radio works. The radio has a speaker out jack that goes into this line level converter that's in that filter board there. That's all discussed, and I've posted my schematics. The fan works. That's the MOSFET and the power control circuit, which I hadn't even breadboarded. I just kind of built it onto the board in the I've done this so many times now that it's like, alright, I can swing this. But if I go over here, you can see that I have a host connection to it, so I'm going to tell it to turn the fan on. And there we go. So that was the manual command, but there's a mechanism in here. So that's the temperature sense. There's an I2C temperature sensor that's providing that reading, and the TMP102 also gives me this nifty ability. Where is it? There we go. Temperature alert. So on the far right, I have a figure of 110 Celsius for now, which is that's gonna drop way low. There's no way I'm gonna want this stuff getting that hot, but it's just there for example. So 110 on the high side. At that point, the fan gets triggered, and when it falls back below 100 in the middle display, then the fan turns off at that point. So these are adjustable. Yep, software bug. Not sure why that happens. Those two are working just fine. It goes in 2-degree increments. But yeah, all of the bugs I'm finding so far are of a software nature, and most of that because I haven't had all this stuff hooked up before. So you're seeing the initial run. The audio switch circuits appear to be working as expected. One problem with it though is software related. The PA. If I go here, this is the blue is the mute button, so I can turn this on and off. But I don't. Oops. I don't yet have the ability to change them reliably or at will. So kind of just playing with them until something in the audio switch register gets tripped appropriately. I have to a little bit of my construction on that audio switchboard down there differed from how I had it on the breadboard, so it doesn't quite come out translated in software yet. I just have to go and test all the mappings again, and then I can get it working correctly. HU is head unit, by the way, which isn't hooked up. Oops, that's not what I meant. I meant that. Radio right now appears to be the output jack. So what should be HU back here, this wiring harness, there's an 1/8" audio jack coming off of it. There's the PA speaker. So that that audio jack runs up to my computer. So the computer does its thing up there, and it's kind of behaving as if it were the head unit. It's just pass-through amp right now, but I should be able to turn that on. That's the brightness level sensor. I knew that was working. Baro sensor's working. The inclinometer, that's its idea of down. There's no way I'm going to pick it up to set its idea of forward right now because that's going to be a mess, but why not? I'll get inaccurate readings. So the inclinometer, it's not storing its calibration data yet, and I have yet to adjust it so that it doesn't display the minus symbol, because for pitch and roll it's going to be pretty evident to the driver which, you know, they don't need to know plus minus, they know which direction they're listing. So the button, the resistor ladder is doing its job. There's pretty good stability in between readings, so satisfied with that. Oh, that's in there too, but it's not, as you can see, it's changing the button output, but not the analog sensor read. So these 4 chrome buttons here all change the analog sensor read, but the toggle switch does not, but it still gets incorporated into that value. And that's used internally for software. So all of those buttons represent a bit in a register. That's the battery indicator. So I've never seen this run either. This is new. Basically what this is on the far right here, the 9.5, we have the panic voltage. So that's the setting below which the machine starts, you know, being concerned about its battery life, and it can start taking measures to preserve it, such as shutting off the Raspberry Pi, which isn't hooked up to this thing yet. I'm using my full-blown desktop. But the voltage reading over here is not correct. That's coming off the voltage divider, and I was having to guess at what the software scaler was going to be by the time the voltage made it to that ADC pin. So on that filter board back there, and again I have the schematics for this posted, the voltage divider is meant to take 15 volts DC, which, you know, I've built in a little about 10% fudge factor there. It's meant to take the 15 volts DC and drop it down into the 3.3 range, 0 to 3.3 volts. It's fed through a Zener diode first, so that anything above 3.6, in practice it's much lower because it's such a low current circuit, but anything above 3.6 just gets shunted to ground. It seems like it's being a little overzealous, because I set this scaler in software based on calculation, and obviously that isn't correct when the voltage ought to be reading, looks like 11 and a half, 12 volts. So that'll take some adjustment as well. PA volume, that works. That adjusts the volume as expected, and that digital potentiometer is on that mess of a board back there. All of this can be set by the host, by the way. You see me doing this here, but I can also let's set it to 17. So I can also do it from the host, which means the Pi can do it on its own. APRS, that's not working yet. Host pass-through. The reason this is here is it's going to be a hotkey kind of a system, so I can use this panel to send commands directly to the Pi. There's no good way to put a keyboard on this thing really, which is okay because you can use timing and binary digits, and those 4 buttons are 2 to the 16th, so 16 independent commands just from that's even without timer traps. So a lot can be done with a little bit, but it's going to be kind of weird to use for anyone who's not acquainted with it. So that's it. I've been pretty impressed with the Teensy so far. It's very easy to use. I really despise the Arduino environment, but the chip itself is quite capable. So all of this stuff is being run off of my scheduler. So that's what's managing all the different timing events inside of the system. As soon as I get the APRS hooked up, the software here is ready for the APRS data. The serial port's all configured. It's set to the right baud rate. I need a little bit of help in the TNC stuff, or I'm sorry, the AX25 frame decoding right now. But before I can really attack that, I have to actually get the thing decoding. The Arduino TNC has been quite frustrating because you need to really drive the pin. I tried a couple of tricks, which is what you're seeing on that board there. It's an amplifier after giving up on my tricks. I tried a couple of tricks to see if I could reduce the drive requirements on it, and no dice yet. Inspiration still might strike, but it's been put off for the moment. I've been focusing on getting this stuff transitioned off the breadboard. So that's where we stand. There are the 3 MOSFETs, only 2 of which are hooked up. One of those is driving the fan. The other one ought to be driving the PA, but for some reason the PA is being driven despite what the setting on the MOSFET is. So there's some, I don't know what's going on yet. It looks like, you know, one of the posts on here is grounding and providing an alternate ground path. The in-channel MOSFETs are best used as low-side switches. Because of the shared ground, I might end up having to use a TIP42 or some similar PNP transistor in order to drive that circuit. TIP42 ought to do the trick. I believe those can handle 4 or 5 amps, if I'm not mistaken, and I don't expect that PA amplifier is going to draw that much. So as soon as I get the radio hooked up, I will be able to test some of my other code in here that it's written and it's been sitting idle. I built it from spec. To be honest, I'm pleased everything has worked this well thus far. No magic smoke. Everything's running smoothly, minimal heat. There's very, very little draw from the 3.3 volt side. Almost no heat coming off of this PA or the DC-DC that's driving it. I think the PA amplifier is going to be used, you know, a little more than half the spec that it's designed for. So the output to the speaker is going to be at tops 30 watts, and I think this DC-DC is capable of pushing something like 60. So work continues. Oops, that's actually what I wanted. Let's see if I can make it chirp, which I successfully did before. Ooh, I got the radio. It's just on the weather station right now. Correct, correct, incorrect. So the radio volume, that's coming off the speaker adjust on the radio volume, so I could grab that volume control knob and change it further, but this is what's important. Not everything in here can be done that way, so it's going to take too long. I need to build in a timer trap to make that spin faster. I can jack this up to 50, and you see the volume difference immediately. Beautiful. Absolutely beautiful. That's it.